Hey guys, hope you are well. In this video, we are going to talk about the evolution of data center architecture. We are living in information age. Just look at how our life have been surrounded by all these social media apps like Facebook, Twitter, Instagram, YouTube, Google Map. Have you wondered how we get to where we are today? Remember 10 to 20 years ago, web apps or so-called monolithic apps were permanent. They were built on the client and server architecture, where everything are kept inside a single powerful piece of hardware. When the time comes for scaling, it usually happens vertically, meaning beefing up the hardware by upgrading capacity within the physical limit, like storage, CPU cores, memory, and so on. Regardless of hardware cost, this way of scaling is impractical. So, do you think that the current social media app like Facebook can be built on top of a client and server architecture? Definitely not. So, the new way of scaling is by scaling horizontally. Split the big monolithic apps into smaller microservices and distribute them across different servers. These microservices are decoupled from each other and they can be scaled individually. This allows changing component quickly to keep up with business growth, which is the commonality for all these social media apps. Enough say about the comparison of the high-level app history. Without support from the underlying network infrastructure, none of them would be possible. So let's turn to the network side. Client and server architecture. If you are a network engineer, you should be very familiar with this. A network architecture that serves the web-based app really well. Traffic above the aggregation is routed northbound to the internet, where southbound traffic to the server is forwarded via bridging. The dual aggregation switches or the access switches here are of course to provide redundancy. This architecture works well until the change of the application. Let's take a brief look at how Twitter works as an example. Twitter is a heavyweight system. The estimated write load is 100 million tweets per day. The read load is 28 billion tweets per day. So this means on average there will be around 12k tweets and 330k read requests per second. And this number are growing too. At high level, Twitter is a distributed system that offers high availability and scalability, and you can tell by looking at their system design. For instance, the sharded data store that are distributed across different servers. That will increase the scalability and availability. And also the layer of caching system. It will improve the read efficiency. So usually a single read request will entail a series of backend operations, which are mainly server-to-server communication. For instance, subtasks on querying the cache or the sharded data store, client response aggregation, or the data store replication. So why the aggregation and access architecture is not good enough for supporting modern app? Here is why. The unscalability. The flat and learn nature of spanning tree is not scalable as the network grows larger. VLAN limitation. The 12 bits VLAN ID renders only 4096 VLANs. Burden of app. Since the aggregation layer is the layer 3 termination, it has to answer app. With the advent of the virtual endpoints, the size of app entry grow exponentially, which burden and make the control plane unmanageable. Failure domain. Spanning tree prevent the use of more than 2 aggregation switches. In the event of hardware failure on one of the aggregation switches, the limited bandwidth of the remaining switch will cause congestion to the application traffic. Unpredictability. For whatever reason, if a spanning tree peer fails responding to hello packets, Other peers will trigger a lot of back-end work to figure out new path and routes, which often burden the control plane of the switches. An overwhelmed control plane can cause loop and broadcast storm. Complexity. The implementation of spanning tree in data center network will usually include other protocols and failure detection mechanism. For instance, per VLAN spanning tree, multiple spanning tree, trunking, multiple gateway protocol like HSRP, VRRP, and link failure detection mechanism. All these additional protocol mechanisms will increase the complexity of the bridging solution. If there's a failure, it will be very difficult to troubleshoot. Inflexibility. It is impossible to span across VLAN between two different pair of aggregation switches. In summary, although knowing of all the limitations of the old architecture is not good enough, the good news is the architecture, which I will talk about on the next video, will better meet the demands and address issues. Thanks for watching. If you like my video, please like and subscribe. If you have any questions, please leave it to the comment section. I will get back to you. I'll see you on the next one. Bye.